This is a robotic ukulele, and it's about to play a song entirely on its own. So I was doing some shopping online the other day, and I bought myself a brand new ukulele. The only problem is, I have no idea how to play it. And it turns out that learning a new instrument is hard. And the more I searched, the more confusing it got. But it got me thinking, why don't I make a robot that plays the ukulele for me? I mean, what could go wrong? There are two ways to make a sound on the strings, picking and strumming. Picking is when you play a single string, and strumming is when you play them all at the same time. But both of these things are quite tricky to implement. We could attach a pick to a servo so that as it spins, the pick hits the string. But what if instead we put a single servo on a slider? The pick would then be set at an angle before being pulled across the strings. This way we can pick and strum using the same method. My plan is to place a linear rail across the body of the ukulele. The linear rail has a sliding block with ball bearings, and it will be attached to a belt and pulley system so that it can be moved up and down by a stepper motor. So we figured out how to pick open strings, but that's just the start. If we want to play a full song, we need a way to change pitch. Normally, you'd press down on the strings at the fretboard, but we can't exactly do that here, or can we? This is a solenoid. Inside, there's a powerful electromagnet that when energized extends outwards, and it should have enough force to push the strings down onto the fretboard. So I've decided to use lots of them, one for each position where we want to press down. To control them, I'll use an Arduino with a motor shield. Now this isn't exactly what the shield is meant for, but with some custom code, it should be able to control up to 8 solenoids at the same time. I haven't actually tested this, so there's a chance it won't work, so we'll just have to wait and see. Now that we've got the parts here, I can already tell that making a design for this isn't going to be easy. You see, there aren't any attachment points. So here's what I did. I took a picture of it first, and then designed everything around that. There are 2 bass pieces that sandwich the ukulele, and they're joined by a linear rail in the middle, as well as some other small parts. Let's print off the parts and build this thing. I'm putting the mounts on the bass first. Then we can add the stepper motor, and I ran out of material halfway through printing the other side. So I ended up fixing it with super glue before adding a mount for the idler pulley on top and the Arduino on the side. The base is done, so now we can attach it to the ukulele. I'm adding this part to hold the servo. It has a slot for the belt and it's placed on top of the sliding block. Nice, it moves now, but the pulley doesn't quite line up, so I had to make it higher. Let's finish getting the belt attached. Okay, moving this by hand is one thing, but I want it to be done automatically. And for that, I need to add some electronics. This is a driver module, and its purpose is to control the stepper. So I've got it hooked up to the Arduino via the shield. Here's the wiring for the shield and the breadboard. Now let's see if it works. Nice, but we're not quite finished yet since it's missing the picking mechanism. After some code, I got the pick moving before adding it to the rest of the system. Did you see that? Let's take a closer look. What's happening is the pick is lifted up to get over the strings and then dropped back down in order to play them. Once the position of each string is carefully programmed in and calibrated, it can pluck each string individually. And it should work in both directions. But there's a problem. and I think it's to do with spacing. There's a flaw with the design, and in hindsight I should have realised this earlier. Depending on if they're pressed down or not, the distance needed to hit the strings changes dramatically. And with so many positions on the fret that could be pressed down, this could turn into a major problem. So I decided to rewrite all the code, completely from scratch, which allowed me to move on to the last part of the build, the solenoid cage. Assembling this thing was way harder than I expected, with all the small wires. But eventually I finished it and got all the solenoids in place. Then I just fixed the cage to the neck and attached these plungers, which help press down on the strings. The ones on the sides are designed differently so that they don't twist out of place. It looks like we're almost done. But here comes the hard part, getting it to actually play a song. That's definitely not supposed to happen. So I'm having a few problems with the pick moving by itself, but it shouldn't be anything I can't fix in code. And based on that, I think we're almost there. Nice. I think we're ready for the final test.